All right, thank you for joining me today. I'm going to be talking to you about greatest common factor, or GCF. All right, so let's take a look at some terminology you'll need to know. First of all, what is a greatest common factor? That is the largest possible number that divides evenly into particular numbers they give you. So they will ask you to find the greatest common factor of a number and a number. And the greatest common factor has to divide in evenly with no remainders. You'll also need to know what a product is, and a product is simply the answer to a multiplication problem. Now, you may not hear me use that today. However, in dealing with multiplication, it may be a term that comes up, and we just want you to know what that means. Finally, factor. A factor are two numbers when you multiply them together that give you a particular product. So at the bottom here, you can see 5 times 4 equals 20. Well, what that means is that 5 and 4 would be considered your factors of 20. So as a quick extra example there, we'll use 12. So think of two numbers that multiply to give you 12, 3 and 4. All right, so 3 and 4 would be factors of 12, as well as 2 and 6, if you maybe thought of that. Or maybe you were thinking 1 and 12, and that's perfectly fine. Those are also factors. So let's take a look at the example of what they're going to want you to do here. And the first one here is find the greatest common factor of 12 and 15. I'm going to show you two different methods, and the first method is going to be the factor tree method or factor method. So to do this method, we're going to use one number at a time, and I'm going to set up just a little mini tree here. Those lines are just representing what factors of 12, or two particular factors of 12, and in this case, it's going to start with 1 and 12. I always like to start with 1 because, first of all, it is a factor of every number. And second of all, if I go in order 1, 2, 3, 4, 5, I'm sure not to miss one. So my next number then would be 2. Does 2 go into 12? Yes. We just talked about that. It goes in 6 times. So my next number is going to be 3. And you can see I'm just continuing it down in order like so on this side. And on the right side is going to be its corresponding factor. So 3 goes into 12 4 times. Now notice the next number would end up being 4 again. Once you repeat, you're done. You've found all the factors possible at that point. So we don't actually need to write 4 because we already have that right here. All right, so what we're going to do now is move over to 15. We'll leave that there for just a moment. Move over to 15 and we're going to go through the same process. So the first factor is 1 and 15. Now 2, can 2 go into 15? No, 2 goes into even numbers only. So we can skip over 2 and we can move to 3. Can 3 go into 15? Yes. 3 goes into 15 5 times. All right, what about 4? 4 doesn't go into 15, so our next choice would again be 5, but you notice we already have 5 there, so we don't need to continue. We're done. We found all the factors possible at this point. So what we're going to do next is compare our factors, and we're trying to find the largest one that they have in common. And again, the word common meaning that they both have it. In other words, they have a factor that is the same. Okay, so do we notice any factors that they have that are the same? You can go ahead and circle them if you want. They both have, and I'll do this in a different color, they both have a 1 and a 1. Do we see any other ones? Yes, they both have a 3 and a 3. So now in looking at these factors, are there any others that they have in common? No. So what is the largest that they have in common? Well, of course, that would be 3. So your GCF for 12 and 15 would be 3. All right, so the next example here, we're going to use that same strategy. And if you'd like to try it, go right ahead. Find the GCF of 30 and 45. So I'm going to start with 30. Do my two little lines here and start going down the factors. We know 1 and 30. All right, your second number will be 2. 2 does go into 30. How many times? 15. Again, if you're not sure, there's no problem with kind of doing a little scratch work off to the side. 2 goes into 3 once, and 2 goes into 10 5 times. We want you to be sure not to miss any factors because the one that you're missing may be the greatest common factor. So you got to be sure. So 2 goes into 30 15 times. Is 3 a factor? Yes, it goes in 10 times. What about 4? Again, if you're not sure, divide it out. 4 does not. What about 5? Yes. 6 times. Okay, so now that we see that we're about to repeat, because the next number would be 6, we already have those, we can go ahead and stop there, and we're going to move on to 45. So we know 1 and 45. Can 2 go into 45? No. What about 3? It does, and if you're not sure, off to the side, divide it, because that can be one that's missed sometimes. 1 times 3 is 3. Bring down the 1, and 3 goes into 15 5 times. So you actually see 3 goes into 45 15 times. This is where those divisibility rules that you learned probably in 4th or 5th grade come in handy. In this case, numbers divisible by 3 will always add up. So 4 plus 5 gives you 9. It actually adds up to a number that is divisible by 3. So that's just something to keep in mind when you work through these. But of course, when in doubt, in this case, you can go ahead and divide it out. All right, so can 4 go into 45? No. 5? Yes. 9 times. What about 6? No. 7? No. 8? No. And again, if any of those you have a question about, divide it out. Then we'll come to 9 again, so we're done. We found all the factors, so let's go ahead and see which ones they have in common. We have 1. 2, no. It looks like we have 3. We also have 5. And as we work our way around the corner here, we see that we also have 15. All right, so our obvious choice here, hopefully, is our only 2-digit number, which is 15. So 15 will be your greatest common factor. And that's a nice, easy way. It is a bit timely. It does take a moment. However, if you do it correctly, you're sure to always find your greatest common factor, no matter what. All right. The next strategy we're going to look at is sometimes called the upside down cake method or the ladder method. It's all the same thing no matter what you call it. So let's look at the two numbers, and we're doing the same thing. We're just using different type of math here, or a different type of strategy really. To do the ladder method, what you're going to do is write both numbers next to each other like so. So this time we're going to use them both at the same time. And what I want you to do is I want you to look at both numbers and think of what number can go divide evenly into both. Okay? And the easiest thing to do here when you're first learning this method is to go with the lowest number possible, or the easiest one possible, which in this case would be 2. Because they're both even numbers, we know that 2 divides evenly into both of them. So what I'm going to do is draw a line, as you saw there. Draw that line, and then put 2 outside, almost like an upside down division sign. And now I want you to divide them. So 2 goes into 32, 16 times. 2 goes into 48, 24 times. If you're not sure, again, divide it out. All right, now we're going to do the same thing. What number goes into both 16 and 24? Again, we can use 2. Why not? If you can think of another one, that's fine. Whatever number you think of, draw the line and put it right outside, just like that. And divide again. 2 goes into 16 8 times, and into 24 12 times. One more time. This time maybe you were thinking 4, and that's fine. You could continue with 2 if you wanted to. Let's use 4 though. It's kind of obvious. Goes into 8 and 12. So 4 goes into 8 2 times, and 4 goes into 12 3 times. Now look what we're left with, a 2 and a 3. Is there a number that goes into both 2 and 3? No. Okay, so what that means is you're done. However, how will we actually get the greatest common factor? Very easy. See these numbers outside over on the left side, and I'll highlight them here for you. Circle them. These numbers right here, when multiplied together, will give you your greatest common factor. So we're going to take 4 times 2 times 2, and when we do that multiplication, we get 8 times 2. So our greatest common factor of 32 and 48 would end up being 16. All right. Let's look at one more of those. All right, the greatest common factor. Notice this time they're asking us about 3 different numbers, and this can happen. They can actually ask you about multiple numbers, more than 3. It's not as likely. However, 3 is typically the most you will see. So let's look at 40, 16, and 24 using this same strategy. Now this is a good example of why you would probably want to use 2, because it's very easy to look at these three numbers and determine, because they're all even, that they can divide by 2. So we're going to start with 2. And in dividing, and usually dividing by 2 is pretty easy to do in your head also. I'm going to go ahead and draw that out. All right, 2 goes into 40 20 times. It goes into 16 8 times. And it goes into 24 12 times. So again, looking at those numbers, can we think of a number that goes into all of them evenly? Let's stick with 2. I realize that 4 can go into all of them, but let's stick with 2 for right now. So you can see 2 goes into 20 10 times, it goes into 8 4 times, and it goes into 12 6 times. And one more time, it looks like they're all divisible by 2. So it goes into 10 5 times, goes into 4 2 times, and it goes into 6 3 times. Okay? Now, is there a number that can go into 5, 2, and 3 all together evenly? No, other than 1. So we're finished. So again, you come over to the left side of your ladder, whatever's climbing up your ladder here, which would be 2, 2, and 2, and you multiply. 2 times 2 times 2. And in this case, you're going to get 4 times 2, or 8. This is not 6, okay? This is 2 times 2 times 2, which means 4 times 2, or 8. So 8 is the largest number that they all have in common. Lastly, a word problem. All right, so how do they implement this in word problems? Well, this is an example. Coach Pryor has 18 soccer balls and 28 baseballs that he's putting into bags. Each bag will have the same number of each ball. What is the greatest number of bags that he can have with no balls left over? Your key word in this that you're going to use greatest common factor, other than maybe least common multiple, would be, of course, greatest. So always look for that. If you know you're doing these types of word problems, that's what's going to be your clue. Now, depending on what method you want to use, I'll leave that up to you. 18 and 28. I'm going to work through this using the ladder method again. You can also go back and revert back and use the tree method if you'd rather. I'm going to find what number goes into 18 and 28 evenly. In this case, it's going to be 2. 2 goes into 18 9 times, and 2 goes into 28 14 times. All right, so looking at 9 and 14, is there a number that can go into each of those evenly? Actually, there's not. So the largest number that these two have in common is actually 2. So to answer your question here, it says, what is the greatest number of bags that he can have with no balls left over? 2. 2 bags. And that is a quick little lesson on greatest common factor. Thank you for joining me.